saying this is in the context of the exhibit.
Right.
You know, viewers will come and there'll be this video screen and they'll have an opportunity to hear your explanation of, you know, what the importance and significance is of this exhibit, the artifacts, and why they happen to be here at UTC. So if we could, let's start with, there are these 5 themes: temperature, motion, metrology, materials, and intelligence. What's the purpose of those 5 themes? How do they relate to UTC?
Well, these 5 themes in many ways represent pillars of the technologies that underpin the products that UTC makes. So if you think about temperature, a lot of what we do is about converting heat or getting rid of it. Things that make people comfortable in buildings, or removing heat from the jet engines, or from inside compartment of an airplane, what you might do to cool. Similarly, when you think about motion, a lot of our work is converting energy to useful work and moving people around the globe or inside tall buildings, all the motion that they need inside an urban landscape, or even the core that makes that possible, such as motors, which really are the heart, the electrical machines that move things. So whether it's spinning a compressor that's part of an air conditioning system or an elevator system. When you think about metrology, that's very key to the precision manufacturing that we do. So a lot of the systems we make work and work so well because we are able to control how we manufacture them, so that over millions of cycles, they still perform similar to the way they did on day one, and they perform in a way that's expected. And so our ability to measure and to monitor the performance of these mechanical systems is key. Materials is at the heart of a lot of what we make, because we make engines that operate at very high temperatures, sometimes even at temperatures above the melting point of the material. We're having to do things to actively cool them. Unique coatings enable things to work in all different environments. So the science around the materials, whether you're talking about for jet engines or things that may minimize frost on air conditioning systems, or what might be needed to be able to have an elevator go 100 stories, the kinds of materials involved in the ropes or the cables are key. And then if you think also about intelligence, while we're a company that makes physical things that move people around the globe, that keep people safe, we also are building intelligence into all the products we make, so that we add greater value for our customers. We also understand their health, so that before someone even needs to make a service call, we know that there's something to do, and we enhance their performance using the kind of analytics and intelligence and embedded smarts that we put in our products. So these 5 areas really define very well foundational technology pillars for UTC.
So looking at these 5 areas, they're represented by objects, inventions, and discoveries of the past. How does looking at these 5 areas and what was done in the past help you look forward?
Well, I think it's a wonderful way, particularly for those of you here in the gallery, to get a sense about the scientists and artists of the past. And the work they did that was pioneering in many ways informs, if not even has maybe a direct connection to what we make today. So the ability to navigate, made possible by some of the clocks you see here in this exhibit, really fits into what we do in terms of being able to control airplanes and elevators and how they navigate and move. The way in which they use unique materials to make very complex machines that would operate over years, I think also is a wonderful example of the kinds of things we do today, where we use unique combinations of materials and coatings in order to get performance over the lifetime of parts. Some of the things we make are still working 100 years later. You know, we're used to a cycle where it seems like every 6 months you're changing the product because we're so used to software and apps, but a lot of the products we make as a company persist for 50 to 100 years.
So these exhibits, articles in the exhibit also kind of represent people solving problems, and they were solving problems with the technology and the tools available then. How has that changed? Is UTC solving problems in a different way that wasn't possible before? Something like physics-based models, virtual environments. How are you going forward? What would be, say, an exhibit 100 years from now? What would be in that a new way to solve problems?
Well, I'd say there are a lot of things that have changed, and there's some things that remain the same. So one is certainly today the problems we're solving are much more complex. So you're involving things from computer science to aerodynamics. And so you're having to bring lots of disciplines together. Secondly, we have a lot of tools that didn't exist at the time of many of these exhibits, such as the computer. Our ability to do simulations that are based on the physics so that we can model on the computer what in the past one might have had to build a prototype and test. We can now do a lot of that virtually. It allows us to get better answers, better designs, and to do that more quickly. But some things haven't changed, and I think the ingenuity and the innovation of the individual and that person working with teams is still the creativity that powers a lot of the unique products that we make as a company. So our folks, our artists, our scientists today have better tools, they have more knowledge, they're working more complex things, but you still need that spark of innovation of the folks that are, in fact, at the heart of the things that UTC is making.
Can you describe some of the, some examples of the way you're solving problems and sort of achieving predicted results in a way that was not possible before?
Well, on some of the things, for example, we're looking at the performance of our engines, such as Gear turbofan. As that was being designed, we came up with a very unique architectural innovation with regard to introducing the gear to optimize it. We were having to estimate and predict what would be the fuel efficiency of this system. And so being able to predict that in a way that we knew how to design it, how to build it, what we could promise to our customers was really key. And in fact, what's very exciting is the engines we're making, this new generation, actually are delivering at or better than the performance that we had predicted. Similarly, on something like an elevator, and you're thinking about ensuring safety for the customer and predicting the life of the rope, as we call it, or the cable that holds that elevator. You need to know how long it will last and how well it will perform in the field at different sites around the globe. So our models allow us to predict life, help us understand that. The safety, sort of the brakes, if you think about it, that work in terms of also moving elevators up and down. We're able, actually now we had a major breakthrough where we're able to model the performance of that so well that some of the certification bodies have been able to accept our models, so we don't have to do all the testing that we had to do in the past in terms of proving the performance. This is also true on our heating, ventilation, air conditioning systems. Some of the things that we're doing today, we're installing heating and cooling in megatall buildings, over 100 stories tall. And some of these have thousands and thousands of different air handling units. And so when you think about how they should perform, often when you're installing that many, it's easy to get the installation wrong, and you may not realize it until much later. With our models, we're able to predict how they should behave, so even at commissioning, we can identify issues that in the past might have taken years eventually to discover. And so we're making everything better from the beginning and even over its life.
So the exhibit also has, as you said at the beginning, these five themes, 5 areas, and many of the artifacts represent somebody working in one discipline, one area. How are these kind of 5 areas converging now at UTC?
Well, I think they converge from the standpoint of some of the things that you think about that we make today. So as we're moving people, it often takes some source of power or propulsion if you're thinking about, say, an air vehicle, and that propulsion naturally generates heat because you're burning a fuel. And so you're needing to get rid of that heat, move that around, and so you have both the motion associated with heat and the removal of heat. Even something such as intelligence. If you think about computers today, where we used to think about how many transistors you could put on a chip, now it's not so much the limitation of how much you can put on a chip, but how much heat you can remove from the chip. Because of all the work that chip is doing, you're generating all this heat. And so a lot of the limiting pieces are our ability to manage the thermal environment. And so you can see just in that you have motion and temperature and intelligence all coming together. And a lot of the systems that we make, you have to make out of unique materials, and you need to be able to measure the performance of those materials, which is in fact the metrology.
And how does UTC bring all these disciplines together and move forward?
Well, I think UTC is, one of the premier engineering companies in the world, and I think what's very exciting is UTC is not narrow in just one discipline, but brings many of the disciplines, like one would see here in the gallery, together in terms of teams of engineers and scientists working together to bring their unique skills together to work on systems. And I think that's really what's very powerful about a lot of what we make. It's not just a single part or a component. It's a very complex system where all these parts have to work well together. And not unlike maybe a clock on a smaller scale, all the complex parts having to work together and keeping time over a long period. And for us, all the different systems and subsystems that have to work well together to perform in terms of what we do in buildings or in aerospace.
So we just talked about this idea of individuals in the past working individually, and I think we talked to Dr. McQuaid about this, but this notion of, I think I saw in an interview with you that it's a contact sport. Innovation is a contact sport. Could you talk about that, what that means?
Well, I think a lot of the heart of innovation is about looking even sometimes at old problems, but in completely new ways. And it's also about bringing different perspectives together. I think that's the heart of those who are considered geniuses. So a genius is able to bring lots of different ideas together and synthesize things in the way most of us cannot. But I think that's something we can begin to replicate with really high-performance teams. So if you bring brilliant people together who represent expertise in different areas, you have them looking together at the same problem, they can then synthesize a lot of the things that it might have taken a genius to come up with in the past.
Said at one point that we make better things in order to make things better.
Right. I'll pause a second because we have some people walking here on the side.
If you wouldn't mind saying that and then explaining how that applies today, and also was that a kind of do you think that spirit was alive and represented in the inventions and things that people were doing in the past that are in that exhibit? Were they trying to make things better things to make things better?
No, I would say so. I mean, one of the things we talk about in terms of what motivates us as a company and our own employees is that we make better things in order to make things better. So what do I mean by that? I mean, we're not just about making our product. Our folks are connected to a greater purpose in terms of thinking about how can we address big challenges in our world? How can we make society better? So whether you're thinking about sustainability, with regard to our climate, with regard to food supply, with regard to safety, security. There are big overarching themes really that are important for us as a people and our society that the products we make help directly address. So as we make better products, we're actually making things better for people in terms of their world more sustainable, having them be more safe, having them be able to travel to different parts of the globe, to be able to have a better standard of living, to be able to enjoy where they live. Hence, the two are connected. And so as our folks make better things, they're always thinking about how can we have an impact on our world, on our community.
If you UTC employees are going to see this exhibit, are you picking that up?
Yeah.
Well, you go walk through.
Yeah.
It's okay.
They don't realize we're filming.
It's quite a
Yeah.
expression.
Are we going to do outtakes on this too?
Yeah, that would be nice.
Yeah.
Sorry, now I forgot the question. Sorry about that. When UTC employees go through this exhibit, what do you think might inspire them? What would they see, and what do you hope they would take away from this exhibit?
Well, I hope as people go through the exhibit and see what they see, that they're in a sense of awe, wonder, inspiration, from the standpoint of what historically is amazing what people were able to do with so little. And I think it's the ingenuity they brought with the tools at their hand. And so today, with so many more tools that we have, if we bring that same sort of energy, enthusiasm, wonder, curiosity, we can also envision things that people would not have thought possible. And I think as one looks around the room and sees all the things here, you can see brilliant people trying to address very practical problems of the day that they're trying to solve, having an impact beyond building something to address the one problem that was motivating them.
So what if the people in the past were solving problems that changed the world in some ways, and UTC, as you said, some of the inventions this company's have changed the world. What are some of the problems and challenges that you see ahead of us that UTC is going to address?
Well, certainly, as you think about the things we made, our elevators today move the equivalent of the world's population about every 3 days. And if you think about it, before the modern elevator and what Elijah Otis had invented and what we're building, you wouldn't have tall buildings. You wouldn't have the modern cities that we have. As you look forward and you think about some of the challenges of mega tall buildings, future places of work, as you think about the challenges of moving people safely around the globe, about the challenge of feeding our world population, where we actually make enough food for all the folks in the world, but still 1 billion people go hungry every night, and it's because of the infrastructure challenges. We're making things that keep food from spoiling, going from farm to fork. So there are a lot of things about the sustainability of our planet. There are a lot of things about the performance of our systems. You might even think about the challenges of moving around with traffic and congestion and things of that fashion. The intelligent systems that we're making can impact that as well. And certainly there are threats that we face in terms of, we see very much the challenge of cybersecurity. As devices become more connected, that creates even more risk in terms of physical devices being connected. So a lot of our work in the space of intelligence is about how do we ensure the security of our physical devices connected to a World Wide Web. So these are just some of the things I think that are very much on the frontier for us.
You mentioned one of those issues is sustainability, and we're almost done, but some major corporations are really taking this on, and UTC is too. Because that is an issue of the future. Can you talk a little bit about UTC and its role in sustainability and how you're innovating to make that happen?
Well, it's the things I was talking about earlier. In terms of sustainability, we're thinking about the impact of what we do and our products and our world on everything from food to environment to climate and things of that fashion. So the kinds of things that we're doing that are having a big impact, our jet engines today use over 15% less fuel than the previous generation. And so right there, big impact with regard to efficiency, environment, climate. Similarly, what we're making today is quieter. 20 dB quieter in many cases. And so then if you think about the acoustic environment, that also is a big positive impact on the urban centers where people live. Our elevators themselves, one of the things we're doing is looking at regenerative braking. So an elevator uses energy as it's moving either a load up, but then actually can have gravity work for you, and if it can recover sort of that benefit in the braking, you can actually reuse some of that energy you expended moving the elevator in the other direction. And in doing that, they use 75% less energy than traditional elevators that don't have a regenerative system. And I think also in terms of challenges for today, one of the challenges is because we make things and we've been very successful, we have lots to make. And so the challenge of manufacturing in new ways is really at the frontier of what we're doing. And so I think it fits very much in this exhibit that the work we're doing now to make things additively, where you build it up almost a grain of powder at a time, or a wire at a time, as opposed to having a big block and carving away or sculpting. We're changing the way we manufacture some of the parts that we make. And in this, the science of materials, the science of metrology are going to be key in our being able to reinvent how things are made.
So UTC makes, oh, go ahead. Okay, this is the last question, but what's significant about UTC is that you actually make things. And what is it that brought you to UTC? What sort of got you here, and why, what inspired you? What makes you come to work each day?
Well, I think the thing that's drew me to UTC is that it's a company for whom technology is in its middle name. And it's a company that puts a great value on being advanced in terms of technology, but also has clear line of sight to what it's good for and how is it going to benefit in the market. A lot of times technologists work in spaces where they're inventing new things, and they have to do a lot of work to figure out how do I transition it to a product, how do I monetize it, how do I take it somewhere where it can be of value. Other times people may be on the end of simply making the product, and it's simply almost like a commodity, and you're trying to just do that a little bit more efficiently, but you're not really infusing new technology that provides a differentiator. UTC brings together the innovation as well as the market. And so this idea of reinventing how we do things in the world and having a path to deliver it is what is very powerful about a company like UTC, and being able to do that on a global scale.
So when you see things like the buzzwords of today, big data, additive printing, those kind of things, how does UTC approach these kind of emerging technologies?
Yeah, one of the things I really respect about UTC is how it's a very disciplined company. And so you often have in technology a lot of things that show a lot of promise at the beginning, and most new things have what's often called a hype cycle. And so there's all this euphoria about all the things that could possibly be done with it, and then when you find out a lot of these things aren't practical, there's almost discouragement that all these things we thought could be possible aren't, but then eventually you come to a different plateau where you see what's really possible with this new technology. So what we don't do is jump on the bandwagon just because it's a buzzword, but what we do is envision, well, what is on the other end of that hype curve? What is this new reality and potential that's there in the future? And we seek to accelerate bringing the future forward. And so what we do is identify how these technologies could change what we do, how it could benefit our customers, and tunnel in and focus on that right away, and to be efficient in how we develop technology.
Great. Okay, I'm good. You guys have anything? Shot good? That's good.
So,
We do it in there. You wanna-
Yeah, just
Keep that
room
for-
tone for 15 seconds.
Okay. That's good.
That's good. Great.
did you get, I don't know if